Good morning, Pre-Algebra. Today we're on 12.3, and I've got to say, a lot of this is going to seem familiar. So again, good news. We're building on previous knowledge, and we are adding to it, going one or two steps deeper, so that way we can all just kind of find success. All right, let's get started. So polygons. That's a compound word. Poly means many. Gon is a type of shape. So a polygon is a closed figure that is important, but it's also simple. So it's not like this complicated squirrely doodad. No. It's a simple closed figure made up of line segments. So all of the line segments meet each other. They have ends. There's no loose ends for polygons. So we've got all these ones categorized as simple or not simple, closed or not closed, and then segments. So now notice here how the circle is not technically a line segment. It's not a line segment because it's got a curve. So anything that curves is not a line segment, therefore it's not a polygon. Okay, we're gonna keep our eyes out for things like this. Yes, a circle is a simple shape. I think this one's a little bit different because it's more of an oval. Circles, they kind of exist in their own realm. So in this case, this is the only one that would be classified as a polygon. Okay. We have our types. And again, these are going to look super familiar. So concave, convex. Convex means that it's obtuse or wide angles. Concave means, look how this comes in, it caves in. So this shape has an entire side that caves in, boop, where this one, none of them cave in. Rather, they, if anything, they just kind of, all these corners jut out. So I've got a definition over here. Concave polygons have at least one interior angle, so that's this guy. It's inside, it's an angle inside that has a measure greater than 180 degrees. All of these interior angles, 1, 2, 3, 4, 5, this should be closed, however, but all of these 5 angles do not have a measure greater than 180 degrees. They're all less than 180 degrees. Whereas this angle here, if I start here and measure all the way, well, it's beyond a straight line, so therefore it's greater than 180 degrees, making this polygon concave. There is a whole list in your textbook, page 500. Go ahead, check it out. Right, we know a lot of them. Rectangles, rhombus, different types of triangles. I'll get into some of those later. Octagons, nonagons, dodecagons, so on and so forth. Check it out, page 500. But I want to talk today about regular polygons. So a regular polygon has these two primary factors. Yes, it will be important to know these two things. That a regular polygon has all sides equal, just like this triangle, right? And all angles are congruent. Just a quick reminder, these little dash marks indicate that this is congruent to that, which is congruent to that, as opposed to, let's say I had a rectangle. These two are congruent with each other, but they're not congruent with these guys. So for this rectangle here, the 1 dash side is equal to the 1 dash side, and the 2 dash sides are congruent with each other, but it's different because it's a rectangle, right? Okay. Here's another one. Square is a regular polygon. That's a regular quadrilateral, 4 sides. all equal angles. Now this, not all angles are congruent, but all sides are congruent. Not all angles are congruent. Therefore, ... it's not regular. Okay. A lot of this should be review. I hope it's making sense for you guys. Again, leave a comment below or reach out to me and I will be happy to answer any questions you guys may have. So for our triangles, this is how you measure, or rather, this is how you categorize different triangles based on their sides. You could also categorize triangles based on their angles. I'll get to that in just a minute. So we have these three types of triangles. Again, one tick mark means that it's not congruent to that, which is also not congruent to that. None of these are congruent. This one has two sides which are congruent, but not the third. And this one has all three sides congruent. Scaling triangles, no sides congruent. Isosceles, only two of them. Equilateral, equal lateral, equal sides. All sides are equal. Okay, again, equal and congruent are basically the same term. This is how you categorize triangles based on their angles. So I think you can see all the numbers inside. That's 20 degrees, 30 degrees, and 130, 45, 60, 75. Again, all triangles have the interior angle, which adds up to 180. So if you add all that together, you'll get 180. Same here. Again, these are the definitions. Okay. Like I mentioned, the sum of every triangle's interior angles, that's the angles inside, is 180 degrees. Every single time, that's what it's going to equal, which will probably come into play and use sometime in the future. So if we have this triangle here, A, B, and C, and say we're looking for C, the measure of angle C. What we're going to do is we're just going to add these together, 136, and subtract. That's the nice thing about geometry, is a lot of this is just simple addition and subtraction. Okay, got one more page for you guys. So those are triangles. Here are quadrilaterals. Different categories for quadrilaterals based on shapes, angles, sizes, etc. So a trapezoid has at least one pair of parallel lines. Here's what trapezoids look like. So they can look like this. This guy has two right angles on the inside, but then it's kind of an extendo line here, which is parallel here. Or this is more your traditional trapezoid, which comes in here. Okay. Parallelograms have two pairs of parallel lines. Traditionally look like that. It's kind of a nice diamond shape. Rectangles. Rectangles have four right angles, and they're technically also parallelograms because they also have two pairs of parallel lines. So we could say technically also a parallelogram. Oh. Technically also a parallelogram, and it's true. You could call a rectangle a parallelogram that has four right angles. That'd be very true. Okay. A rhombus has four congruent sides. but they're usually like a square that's tipped over. So all these sides are congruent. These are also parallelogram. Wow. Parallelogram. Because all these opposite sides are parallel. And then finally we have a square. Now notice how I called it a rectangle here because it has 4 right angles. So it's a combination of previous 3. And again, like we saw on, I believe it was the last or the first page, a square is a regular quadrilateral. Okay. Now here's a little added bonus. When we're talking about diagonals and sums of angles, so the diagonal is going from one vertex, right? A vertex is a corner where 2 lines meet, and crossing through the shape. But from this place, how many diagonals can you reach? Let's talk about interior angles. So the sum of the interior angles here are 180. And for each added side, I'm going to multiply that by an extra 1, right? So this is technically 1 times 180. This is 1 plus 1, 2 times 180, 3 times 180 for this is a pentagon, and then this is a hexagon. And this could go up until you reach however many sides you can. This is a key thing to remember. Number of sides minus 2 times 180 is going to equal that. Number of sides times 2, or I'm sorry, minus 2 times 180 equals sum of interior angles. Okay, that is important to know. That's a minus sign right there. Sum, or number of sides minus 2 times 180 equals sum of interior angles. Now for our diagonals, this is our sides minus 3. Like I was saying, from this point, how many different angles can I draw, or how many different vertex can I draw a line to without touching an edge? Well, there's only one. From here, I can only do that twice. All the other vertexes, I'm going to be drawing on the edge. Can't do that. So I've got 2 diagonals, 3 diagonals here. 2, 3. Here are your 2 equations that you've got to know. All right, guys, if you have any questions, please let me know. Otherwise, love you a bunch. Bye.